Welcome to solverfy.
In this problem, we have a radio broadcast being received at a distance of 12 kilometers from the point source of the antenna. And we know that at this distance, the electric field strength of the signal is 0.12 volts per meter. And using this information, we want to find the average power of the transmission. So first we should consider the concept of average intensity. And it's defined as average power over the area that the signal is being spread across. So if we have our antenna and it's transmitting some signal, initially, right at this point here, all of the power is concentrated at a single point. But as the signal is being broadcast in spherical waves, we know that the same amount of power is being concentrated or is being distributed all across the area of a sphere of distance r. So at a distance r, all of that power from our point source is a little bit less intense than it was because it's now being distributed across this entire sphere. So we know that the formula for the area of a sphere is 4 pi r squared, so we can just plug that in our denominator. And we also know that another way to write intensity in this context is 1/2 epsilon naught, which is vacuum permittivity, speed of light c, times our electric field strength squared. So looking at this expression here, we know that 4 pi is constant, radius is given, 1/2 epsilon naught, speed of light are all constants, and we're given our electric field strength. So all that's left is our power term, which is what we're searching for. So all we have to do is rewrite this a little bit to isolate for power, and then plug in our values, and we should get an answer. So power equals, let's see, this will be 2 pi epsilon naught, speed of light, r squared, electric field strength squared. So I'll leave myself a little more room and rewrite this. So now I'm just going to plug in all of those values directly. So we have 2 pi, and our epsilon naught, our vacuum permittivity term, is a physical constant that we know is 8.85 times 10 to the negative 12 joules per volt squared times meters. And also our speed of light, of course, is 3 times 10 to the power of 8 meters per second. And let's see, our radius is 12 kilometers, or 12,000 meters. So 12,000 meters, and that should be squared. And then our electric field strength, E sub naught, we know is 0.12 volts per meter. And that also should be squared. So if we plug all of this into our calculator and round to 2 sig figs, we find a result of 35,000 joules per second, which is equal to 35,000 watts, or simply 35 kilowatts. And that is your answer.